Welcome everyone to Fujitsu's Carrier Ethernet webinar series. And the topic of our series today will be Leverage Your Access Networks through Ethernet Exchanges. My name is Ralph Santitoro with Fujitsu Network Communications. I'd like to introduce two of our other speakers today, Aaron Dunn, the Director of Research Services with the Vertical Systems Group, and Jeff Brown, Vice President of Carrier Services with Covad Wholesale. Thanks for joining us today. And as part of our Carrier Ethernet webinar series, it's a series of webinars we've been providing on topics anything Carrier Ethernet, focusing on technologies, applications, and services of how to use Carrier Ethernet as a next generation networking technology. I'd like to now introduce our first speaker, Aaron Dunn with Vertical Systems Group.
Thanks, Ralph, and good morning or good afternoon, everybody. So my name is Aaron Dunn, as Ralph just said, and I direct the research practice for Vertical Systems Group. Vertical is a market research firm and strategic consulting firm specializing in wide area data networking. We're based in Boston, Massachusetts. This would be my time to just do a quick Go Bruins shout out for tonight. And I'm certainly happy to share some of our recent research on business Ethernet services, Ethernet access trends, and the emergence of Ethernet exchanges. So again, I want to thank Ralph and the team at Fujitsu for helping or for asking me to participate today. And just a quick note to let you know that the data points that I plan to present today are all excerpted from Vertical syndicated research programs. If you have any questions about the data that I present or any questions about Vertical's research, my email is at the end of this presentation, so certainly don't hesitate to reach out to me. So first is what's driving Ethernet. And we all know what's going on, that the Ethernet services is a big market. But simply, Ethernet services fit the speed and application requirements for businesses today and provide a scalability path for retail and wholesale service deployments into the future. We're seeing new enterprise applications like cloud, lots more pervasive use of applications that have been around for a while, like video and data center connections for backup or disaster recovery. We also see continued access to the Internet and VPNs, lots more Layer 2 and Layer 3 for many types of devices. So that's just a quick overview of what we're seeing as far as driving the demand for Ethernet. And another point that we'll hit on later in the presentation is we're seeing service providers aggregate many low-speed legacy services or legacy circuits onto a single high-speed circuit capable of carrying traffic from multiple apps like backhaul, triple play, and telepresence. So in short, Ethernet now is the new T1. So I'm going to spend just a moment here on who's buying Ethernet. Most Ethernet ports are delivered to enterprises that are migrating their networks from legacy and IPVPN services to business Ethernet. Migration for dedicated IPVPN service is the largest source of new Ethernet connections. Most of these connections are TDM access to VPN at T1 speeds. Legacy services like Frame, ATM, and Private Line account for about a third of the base of Ethernet customer connections, and again, most of these legacy connections are at T1 speeds or below. We'll hear more from Jeff about how this migration profile lines up with Covad's service offerings. In fact, Covad calls their 3 meg Ethernet service the T1 killer, so that's kind of interesting. Moving forward here's a little more detail now. The last two slides show why Carrier Ethernet is in demand, but here's a bit more detail. Our latest research predicts that worldwide market for business Ethernet service will top $44 billion by 2015. Business Ethernet is the fastest growing strategic wireline service. Now we see a lot of wireless that's growing extremely fast, but as far as wireline services go, this is the fastest product for data services worldwide. Equipment vendors like the folks here at Fujitsu continue to deliver and develop future-proof Carrier Ethernet solutions that not only improve operations, but enable new service offerings and address some of the challenges that we see to widespread business deployment. Revenue growth for retail Ethernet services is projected to exceed, I think it's about 18.2% annually through 2015. and market demand for business Ethernet is growing across all regions of the world. Just a couple of notes here on this that I wanted to make is that Vertical defines business Ethernet as the network services component of carrier Ethernet. Secondly, our projection here that you see the little note includes revenue that's generated from Ethernet Internet access, private lines, virtual private lines, metro LAN services, long-haul VPLS services, and something we call e-access. Now, our e-access definition differs a little bit from the brand new definition that the MEF has come out with, and Ralph will hit on that a little bit more later. And also, another note that I want to say is that Ethernet services are the primary driver for Ethernet exchanges, and we're going to hit a little more on that later. And the other thing is that wholesale services have a significant role in the delivery of Ethernet services, and the next two speakers will bring a lot more detail onto that fact. So this is a look at how the ports that generate that $44 billion that we just saw are delivered. 74% of new ports delivered worldwide are on net, meaning the service provider owns the access infrastructure that delivers the port. This is the preferred access method, of course. And service providers, this is the preferred access method, and it's over many different types of media: fiber, copper, T1, T3, coax HFC, and other types of media. Service providers are actively building and buying networks that can expand their footprint, specifically over fiber. The other 1/4 of new business Ethernet ports require a partner provider to deliver the access connections. And how a service provider is doing that now? Usually through a bilateral NNI or a wholesale agreement, or we have this new market called Ethernet exchanges that's coming online now that's offering a different opportunity. So a little more detail on how service providers utilize Ethernet over any access technology to deliver business to Ethernet services. We just talked about fiber is the primary access technology, and direct fiber is the preferred technology for delivering Ethernet services. Again, the goal is to deliver Ethernet services over any media and any technology, any access method, and have it look the same to the enterprise customer. The mix of delivery services it differs. We have lots of other access technologies, and we're going to hear from Ralph at Fujitsu and certainly from Jeff at Covad about the other access technologies that we're seeing out there, such as SONET DWDM, bonded T1, bonded copper, coax HFC. So lots of going on here as far as the service delivery of Ethernet. And so Ethernet exchanges, as I mentioned earlier, are emerging as an option that enables service providers to more easily meet the goal of delivering Ethernet services over any media and any technology and serve off-net locations using wholesale Ethernet access. An Ethernet exchange, as Vertical defines it, is an open marketplace solution for the interconnection of Ethernet services among providers. There's lots of providers. There's lots of participants. At this point, they're defined as buyers and sellers and Ethernet exchange providers. The MEF has done a terrific job in developing service definitions and the Global Interconnect Initiative specifically that promotes standard-based interconnection of these carrier Ethernet networks. Some of the names that you may have heard of as far as Ethernet exchange goes are Xenix, Equinix, Mutual Tandem, and Telex. There's many other providers that are out there or planning Ethernet exchanges, but those are the four that came on board first. So I just wanted to get a little more detail out there on Ethernet exchanges and a little more detail on the participants that we're seeing in Ethernet exchanges. So, and I know there's a lot of you out there listening now that fall into some of these participant segments: incumbents, competitives, cable MSOs. So the top three that I just mentioned are the original participants and the ones that are directly benefit from an Ethernet exchange. An Ethernet exchange expands the wholesale channel for Ethernet services for all of these providers. And in addition to the cable MSOs who are relatively new to the business Ethernet services market, this is a new sales channel and a new wholesale sales channel that they can leverage their existing Ethernet footprint. So good news for a lot of these folks, and especially the folks that don't have a lot of carrier interconnect agreements already in place, some of the smaller competitive providers, and definitely the cable MSOs. We're seeing some interest from the cloud and specialized providers because this is a brand new marketplace that they can distribute their product, and they can connect in one spot to a lot of different carriers that they require access to. So if you're a cloud or a specialized provider and you don't really want to spend a lot of time on the networking component, you want to spend a lot of time on what you do well, then this is a great opportunity also. A little bit of interest out there from enterprises, not really seeing much there, but it's on the table. Specifically enterprises, Fortune 50s or media enterprises, financials that really run their enterprise like a carrier would. And then wireless operators that will utilize an exchange to aggregate multiple backhaul traffic, or they can use an exchange as an aggregation point. At this point, we're seeing limited use of this and limited interest from the wireless operators, but again, there's a lot of talk out there about could this be a market. So the growth opportunities for each of these participant segments are dependent on the stabilization of the Ethernet exchange business models, and we're seeing those models stabilize now. And so looking to the future, Ethernet exchanges give all of these participants an opportunity to leverage their access networks for new wholesale Ethernet service revenue. And that is pretty much the end of my presentation. Again, if you have any questions or comments or require any additional information from me, my contact info is right here. Don't hesitate to reach out, and I am available for questions at the end of the conference of this webinar also.
Thanks, Erin. That was very informative. And what I'd like to do now, one little housekeeping piece, is please feel free to ask questions at any time through the chat window, and we will be addressing those questions at the end of the webinar. And so what we'd like to do now is, before switching over to the next speaker, myself, we'd like to go ahead and conduct a poll with the audience. And so you see a poll question out here, and basically the question is, as a service provider, how do you interconnect with other service providers today? And the four choices are basically you don't interconnect. The second one is only through direct peering agreements with each provider. The other one is sort of a hybrid where you have mostly direct interconnect, but you go use Ethernet exchanges, perhaps just starting to. And then the final one is mostly direct interconnect, but you are planning to connect through an Ethernet exchange, which means that maybe you're evaluating Ethernet exchanges now, but don't actually have a connection to one. So what we'll do is I'll give you a few moments to answer this poll, and during this time I'd like to ask Erin a question about her section. So Erin, okay. Are you seeing revenue being generated by Ethernet exchanges? I mean, Ethernet exchanges are kind of a hot commodity right now. You read a lot about them, you hear a lot about them, but from a business perspective, are they generating some revenue now?
That's a great question. And I have to say that I've been doing this for a long time, and the topic and the research process of quantifying the market for Ethernet exchanges is one of the most interesting that I've ever participated in, because it's a brand new market. It's certainly volatile. There's a lot going on. There's a lot of drivers. There's a lot of trends, and one of the chief obstacles, should I say, of the Ethernet exchange market is just inertia. Is the fact that service providers have developed these NNIs over time. They have entire departments dedicated to them, and it takes time to offer an option to that. So that being said, we're not seeing a significant amount of revenue being generated by the Ethernet exchange providers. By those providers, I mean the CNIX, Telex, Neutral Tandem, Equinexes of the world. We're not seeing significant revenue yet. In fact, the revenue is just beginning. But we are seeing some ports out there. I mean, there's a lot more seller ports that have come online on Ethernet exchanges now because that's a process that's relatively straightforward. We're waiting for the buyers to really step up to the plate. So at this point now, we're kind of at where I guess in the growth curve of establishing critical mass. So waiting for the buyers and the sellers to balance each other out. So we are seeing ports come online, but not a lot of revenue yet because there's a lot of incentives out there to really get the buyers and sellers online. So it's a wait-and-see game at this point.
Great, thanks. Well, let me go ahead and push these results out. And actually, it looks like they very much mirror your commentary there because as we would expect, most service providers are doing direct interconnect today, but they're participating, evaluating Ethernet exchanges as a new way of potentially opening up some new markets for them.
Yeah, I would say that absolutely confirms the research that we're saying. There's a lot of interest there, and it's just going to take some time to bring it online.
Great. Thanks a lot, Erin. Okay, so next we're going to jump to the next section. And what I'd like to, this particular section, I'm going to talk to you about a combination of EOX gateways and Ethernet exchanges, in particular for wholesale Ethernet access services. And so I'm going to cover basically three topic areas. One is I'd like to introduce you to the new MEF Ethernet access services definitions, which are under development and expected to be standardized towards the end of this year, 2011, and also to show you some use cases of how you can use these new wholesale e-access services to peer with a retail service provider and being able to deliver both point-to-point services, E-line types of services, as well as multi-point E-LAN types of services. I'd like to talk about the wholesale access provider requirements and challenges. So there's some unique challenges with the especially peering at the ENNI with another service provider. And then finally talk about what are EOX gateways and how can they be used with Ethernet exchanges to really simplify and accelerate Ethernet access service delivery. So first starting off with the MEF service types, and again with a specific focus on the wholesale Ethernet access being the topic of this webinar. So just a little basics here. Many of you have probably seen a variation of this slide, but the MEF classifies services in basically two dimensions. One is called the service type, which basically is the type of connectivity that the service provides, and that's where you've heard the familiar E-line, E-LAN, and E-tree service types, which represent point-to-point, multi-point to multi-point, and rooted multi-point type of connectivity in the one dimension. And then the other dimension is based on whether the service is port-based or a VLAN-aware service. And so for these EVC-based services that the MEF defined, the two categories, port-based and VLAN-aware, when a service is port-based, it means that the port or the UNI is dedicated to a single service instance. So what that means is you have a single service or single EVC at that port. And so to give sort of an example of that today, let's say, for example, an Ethernet over SONET service is a port-based service, and where it's only one Ethernet service instance at that port. Now contrast that to a VLAN-aware service, and that allows multiple service instances per UNI or per port, or a multiplexed UNI. So a service provider can deliver more than one service over that same physical port. So you don't have to buy a separate port for each service instance. And the MEF has classified those by using the terms private and virtual private. So Ethernet private line being a port-based service, point-to-point, and Ethernet virtual private line being also a point-to-point service, but allowing multiple service instances at the UNI. So these MEF EVC-based services are defined to be UNI to UNI, or basically enterprise to enterprise, types of services, EVC-based services. Now, the new service definitions that are currently under development are basically for a UNI to an ENNI. So now we've introduced this ENNI, which is more of a carrier type of demarcation point in the network. And so we often refer to these as wholesale services because the service relationship is between two carriers or two service providers, versus in the prior slide, the service relationship is between a service provider carrier and an end user subscriber. So it's more of a retail a retail application. And so just like the previous services, the e-access services are defined into two categories at the UNI. So you have port-based services, which are a single service instance at the UNI endpoint of this connection. So it's a dedicated UNI. And then you also have your VLAN aware types of services where you can multiplex more than one service at the UNI. So that's at the UNI side of the connection. And then at the other side of the connection, it's always an ENNI. And an ENNI, by definition, is a multiplexed and aggregated interface. So one of the unique things you can do with this type of service, with like an access private line or access EPL and an access EVPL, is you can multiplex multiple services at the ENNI. So unlike an Ethernet private line, which is not a multiplex service, it always uses up a port at the aggregation site. With an access EPL, you can aggregate those on an ENNI. So it's similar in some ways, but very different on the aggregation point. So these new access services that the MEF defines, they've only defined the point-to-point ones today, are always between the UNI and an ENNI, unlike the prior MEF service definitions, which are UNI to UNI. So let's take a look at a couple of use cases of these types of services. So one of the most popular types would be an Internet access service provider example. So say, for example, in this case, because we're talking wholesale, let's say that these two clouds are two different service providers. So you have an Internet service provider, and then you have an access network provider. So this model is very similar to today with an ISP delivering a dedicated Internet access service over T1s, for example. They would wholesale the T1 circuit from the local exchange carrier and provide the Internet service to that end subscriber. That end subscriber has really no visibility into who's providing that T1 to them. So this is the Ethernet analogy. So the Internet service provider peers with an Ethernet access provider, and this wholesale access provider, and basically wholesales a connection from them, this case being Ethernet. So the ISP in this example would buy an access EPL in this example to be able to connect subscriber A site to the ENNI, and then they would wholesale a second access EPL to reach subscriber B site and multiplex those at the ENNI. So now both of these customers' traffic are separated, but they're multiplexed at the ENNI for cost purposes. And then what they can do is once they have that connectivity through the access network, the Internet service provider then can deliver the Internet service directly to those subscriber locations. Now, one of the interesting things about the e-access service, or providing a layer 2 access connection to the ISP, is that an Ethernet access service is transparent to the protocol being transported for Internet access, obviously the IP protocol. But this allows the ISP to deliver an IPv4 or an IPv6 service without having to do any type of coordination with the Ethernet access provider, because the Ethernet access provider has no IP awareness in their e-access connection, so that IPv4 or IPv6 passes transparently through their network. The next example is showing an EVPL service connecting two off-net locations. So in this example, subscriber site A and B are off-net locations that can be reached by an Ethernet access provider, and the retail service provider, who has the business relationship with the subscriber, cannot reach site A or B without going through the Ethernet access provider. Now, site C is on-net, so they have connectivity to that. So basically, the retail provider would buy an access EPL to reach site A. They buy another access EPL to reach site B. And then they can deliver, for example, an EVPL from subscriber site C to subscriber site A. And they can also deliver a second EVPL between subscriber site B and subscriber site C. So as you can see, they bought the two access tail circuits, basically the two access EPLs, to reach those off-net locations and allow connectivity to the on-net site C. So another example is, so the current MEF service definitions, access EPL and access EVPL, are point-to-point services, but you can actually deliver a multi-point ELAN type of service by using these point-to-point access EPL tail circuits, which is kind of a unique property. When you think of a point-to-point service, you think you can only deliver point-to-point services over that, but you actually can do much more with these access EPLs. So in this case, you have two off-net locations, site A, subscriber site A and subscriber site B, and to make it more interesting, I actually showed two different Ethernet access providers. So let's say they're in two different locations in the country and they had to peer with two different access providers. And so the retail provider would buy an access EPL from the wholesale access provider 1 on the left side to basically connect to subscriber site A. And then they would buy an access EPL from access provider 2 to reach site B, to be able to reach that off-net site. So now they have connectivity to reach those off-net sites, and they can deliver the ELAN service to all of those sites. So now they have a bridged multi-point service, but using two point-to-point access EPL connections to reach those off-net locations. So the next example I'd like to take you through is an EVPL service example connecting two off-net locations, but in this case, to make it more interesting, we'll mix an access EPL and two access EVPLs to show the differences between access EPL and access EVPL. So this looks very similar to the prior diagram where the retail service provider basically buys an access EPL to reach site A, so subscriber site A. They buy an access EVPL in this case to reach subscriber site B. Now they're buying an access EVPL instead of an access EPL. That will become apparent in a moment why they chose that one instead of chose an access EVPL instead of an access EPL. So then they would, so in this case, now they can provide connectivity between site A and site B, for example, using an EVPL service. And if they wanted to provide an EVPL service between subscriber site B and subscriber site C, they would have to buy another access EVPL to basically reach a multiplexed uni at subscriber site B. And now they can offer another EVPL between site C and site B. So the reason why they chose an access EVPL is because they had to multiplex two different services on the uni at site B. And if they were to purchase an access EPL, they would not be able to do that because access EPL is a port-based service. So in order to deliver this type of connectivity, they would have had to have installed a second uni port at subscriber site B, which would add cost and more complexity. So next I'd like to take you through briefly on some of the wholesale access provider challenges and requirements. So if you look at wholesale Ethernet access services, there's a couple things to consider here. In the past, handoffs between carriers was done via SONET. It was probably the most popular way to do handoffs, and there's a lot of good reasons for that. It's standardized, everyone was able to support it, etc. But now with the new packet-based or packet-centric services, Ethernet is now the preferred handoff technology for a couple of reasons. Number one is the services are packet-based, so obviously Ethernet is a packet-centric technology, much more efficient for providing a packet-centric handoff. And the service providers really want to have a layer 2 Ethernet handoff with their wholesale access provider, regardless of whether they're offering a layer 2 service, a layer 2 Ethernet service, or even an IP service. And the reason why is because if by doing a layer 2 handoff, they don't have to coordinate, do any type of IP peering, have to worry about whether IPv6 or v4 is supported, and we're worried about which type of routing protocols are supported between that peering point. With Ethernet, that all goes away and it's not necessary. One of the other key points is that Ethernet services are delivered over many types of layer 1 technologies. This is both a benefit as well as a complexity and a challenge, because access networks have lots of SONET T1s. You can deliver just maybe starting OTN. You have copper pairs, dry copper pairs, or just or even fiber running native Ethernet. You have all of these different access methods or technologies used in a wholesale provider's access network. And Ethernet is the unifier, so now you can deliver a common Ethernet service over these different access technologies, but you'd like to do that in such a way that's very cost effective and you don't have to have separate equipment required to do the conversions between Ethernet over SONET and Ethernet over bonded T1, et cetera. And then finally, there's a diverse usage of Ethernet in access networks. So as I mentioned before, Ethernet access to Internet or IP services. The retail provider wants to deliver site-to-site connectivity with Ethernet. And then there's backhaul types of applications, so residential backhaul, let's say from a DSLAM to an IP point of presence, or even cell site backhaul to a mobile switching center. So all of these applications need to be supported by the wholesale access provider to be able to enable their retail service provider partner to deliver these to their end user customers. So there's a broad spectrum of wholesale Ethernet access services, each with some of their unique capabilities, but they're all offered over a diverse set of access network technologies. So if we take a look at this a little more graphically, so you have different types of customers that you're trying to reach. You have business customers, you have residential customers, and you have, for example, other carriers like wireless operators, cell towers, and then you're trying to connect up to these different retail service provider partners. So what you end up doing is you have to deliver a UNI on the customer premise side, an Ethernet UNI, and an Ethernet ENI to peer with these retail service provider partners. Now, in between that, you have these variety of access technologies already in your network that you would like to leverage and be able to use those technologies to deliver Ethernet access services. But the challenge is, how do I bridge this? The customers want to start Ethernet in on the left side. They want to go Ethernet out on the right side. How do I make this work over this diverse set of access network technologies in a very cost-effective way? So some of the requirements for wholesale Ethernet access, taking a while for the build here, excuse me, okay. So if you take a look at some of the challenges here, you really need a product that provides flexible VLAN ID and class of service ID marking and mapping. So for example, you don't necessarily know if the retail provider is delivering a layer 2 or an IP service, and you don't know their equipment limitations that they're peering with you. So you need to have a very flexible offering to basically accommodate their diverse set of needs. So for example, their equipment, maybe they're delivering an IP service, so from a class of service perspective, they might only care about an IP diffserv code point that they want preserved for class of service. But in your network, because it's a layer 2 network, you only care about Ethernet 802.1p priority code point as your class of service identifier. So you need some type of flexible way to map and mark between the two to make it transparent to that peering provider. Your peering provider might want the VLAN IDs or the class of service identifiers, like your 802.1p priority code point, your diffserv code point for IP class of service, once those preserved across the network. Or maybe they need those to be remapped because they have a certain number that they need to provide to the customer that might be different than the number in your network being used. And then this is probably the most complex one that needs to be handled is customer tags or C tags and then S tags, being able to swap those, add a tag, remove a tag, add double tags, etc., is a very important capability because, again, the equipment you're peering with your partner provider, you don't know the capability, and they might only be able to support a certain capability that you don't know about, but you don't want to be able you want to be able to peer with them without having to purchase new equipment specifically to peer with them. You want a flexible piece of equipment that allows you to support all of these different permutations. You also want to ensure SLA conformance. So at an ENI, because an ENI is an aggregated interface, you want to make sure that you have equipment protection, for example, switch fabric protection, power supply protection, and link aggregation, because your handoff is an aggregated interface which could have multiple customers all running multiple services. That interface cannot go down. It has to be up all the time. Otherwise, lots of subscribers would lose service. You have to be able to manage your bandwidth in a very flexible way, being able to offer a guaranteed committed information rate or allow oversubscription for oversubscribed EIR, for example. And then you need to troubleshoot your network by providing fault management up to your demarcation point, so the UNI at the customer premises side and the ENI at the peering point side with the other service provider. And then finally, being able to provide performance measurements, latency and loss, for example, across your networks to enable you to offer an SLA to your peering service provider partner, but also for them to use that number in their overall SLA to their subscriber. So what I'd like to do now is push a poll question. Basically, the question is, what type of network technologies do you use today to deliver Ethernet access services? So please select all that apply. So the different choices are if you're delivering Ethernet over fiber, so this is basically native Ethernet over 802.3 IEEE, or if you're delivering Ethernet over SONET, Ethernet over, let's say, bonded DS1s or DS3s, commonly known as Ethernet over PDH or Ethernet over TDM, Ethernet over bonded dry copper pairs, known as like Ethernet over copper or Ethernet over DSL, Ethernet over WDM, or Ethernet over OTN. So please go ahead and answer the questions here, and let's see if we have any questions from the audience here. Aaron, do you have any here that you see? Yeah, so I guess a question for Jeff here. So Jeff, in terms of the customers that you're delivering or the services that you're delivering, what do you see as the most popular Ethernet speed for the markets that you serve?
Yeah, today we really deal in the mid-band Ethernet range. So the most common bandwidth by far that we see on quotes and customer requests is 10 meg symmetrical service. We've done a lot of theorizing as to why that is. I think it has something to do with the legacy TDM, bandwidth partitions, in that when a customer gets to that point where they're looking at more than 5 T1s, it starts to get in that range of being a crossover into buying a DS3. So it makes sense for a lot of customers to consider Ethernet. That's one reason, but I also think because of the traffic demands that Aaron talked about with content, peer-to-peer, et cetera, 10 meg is becoming quite a popular bandwidth speed for business locations.
Hey, Ralph, this is Erin. I wanted to thank Jeff for jumping in there. I was on mute, but I did see a couple of questions that had queued up that were specific to your presentation. Do you have a moment here before you do the answers?
Sure. Mm-hmm.
Okay, so sorry about that. I was on mute. The first question I saw was, how do you see the new MEF e-access service definitions contributing to the growth of the Ethernet exchange market?
Oh, okay. Yeah, that's a great question, Aaron. So I think if you look at the MEF's Global Interconnect Initiative, right, so the first step of that was to define and create awareness of the new MEF 26 specification, which defines a standardized Ethernet ENNI. Because obviously the ENNI is really important as a peering technology between providers, because today everybody has their own proprietary way of doing an ENNI. So that's kind of step one. So that's kind of at the demarcation point. Now the next step is on the e-access side, by providing a standardized way to provide a wholesale provider to be able to provide an access service to connect up to a standardized ENNI now has tremendous value, because now a retail provider who needs to reach an off-net location has a common definition, and the service providers in the MEF that are participating in the development of this new e-access specification said that's one of their biggest problems is they have lots of peering agreements, individual peering agreements with different service providers, and they have to do basically a one-off for every single service provider. And some of them I've heard say they have like 100 different peering agreements, and those are for very specific implementations of an access service. So it might be for an Ethernet over SONET service that for that peering agreement they would need something different if it's an Ethernet over fiber service, for example, because the service characteristics are different. So very, very good question there, but it's also a very important point. So let me go ahead and push this out to the audience here. And yeah, so as expected, but let me ask Aaron and Jeff, DS1's really popular, but Ethernet over SONET probably the most popular. Ethernet over X technology, and Ethernet over fiber also very popular. But dry copper pairs, Ethernet over DSL. From a wholesale perspective, copper pairs available, pretty much everywhere. Getting, supporting, Aaron's vertical systems research on, there's this sort of underserved market that can only be reached by copper. I don't know, Aaron or Jeff, would you like to comment on some of the results here?
I can if Jeff will let me jump in there. So I
That's
had
fine.
a slide earlier on talking about the installed base of Ethernet bi-access technology, and I think it does line up with what you're seeing here. Is first of all, fiber is about 50% of the market. So basically 50% of the ports that are delivered out there today in the U.S. come over direct fiber. And then of the other ones, which is, again, still 50% of the market, so that's a significant amount of technologies that have to be addressed. SONET is the top. You have bonded T1s or bonded TDM, I guess, and bonded copper at about tied for second. And then coax HFC, because there's a lot of ports out there that are being sold by the MSOs, commonly called Ethernet over DOCSIS, and then T3. And I think Jeff addressed the T3 issues, is that if you're going to kind of peel off Ethernet from a T3, it's expensive to do that way, so you do it when you have to. So that's it. And then there's a little bit of other stuff going on in there, maybe some fixed wireless or some satellite, but pretty much lines up with what we're seeing.
Okay, great. And so, Jeff, how about yourself? Do you have any thoughts on this?
Yeah, I would agree with the findings. When you think about the legacy carriers with their TDM networks, and they were trying to serve enterprise or wholesale customers who had a need for Ethernet at the end, the easiest way to do it was to pop an Overture box down at the customer prem and do Ethernet over TDM. So that's very prevalent. There's an existing base of it. I think if you were to actually look at new orders for Ethernet, you're actually going to see a stronger growth trend towards either Ethernet over fiber, which is the ideal solution where available, or some of the other technologies that are mentioned here, like Ethernet over copper. And Ethernet over DOCSIS as well is a very popular choice, probably a little more down market because it tends to be more of an asymmetrical versus symmetrical product.
Okay, great insight. Thanks. So next we're going to move on the next section. I have a few slides, and then Jeff will come in and talk about, he'll be jumping in for the next section. So what I'd like to briefly talk about is EOX gateways and Ethernet exchanges and how we tie this all together to deliver and simplify wholesale Ethernet access services. So if we look at an EOX gateway, so those not familiar with an EOX gateway, what an EOX gateway does is there's a problem space here where you have these retail service providers that want to peer with a wholesale access provider at an ENI, so they want to, moving towards a standard ENI would be great. And then the access provider has all of these different access technologies in their network, and but they don't want to peer with them. They don't want to have a SONET connection, a SONET peering point, or a T1 peering point, or whatever, or a WDM. They prefer to have an Ethernet handoff, have a standardized handoff for all their services, and then basically bridge these together and make it transparent of what the access technology is. So even though they're peering at an ENI, we want to normalize this and make it transparent so they don't really know whether it ran over SONET or over native Ethernet or over WDM or over bonded T1s. And so where an EOX gateway comes in is it provides this normalizing function where you can have Ethernet over SONET come in, or Ethernet over bonded T1s, or Ethernet over DS3, Ethernet over SONET, and could come in there, normalizes it to a standard Ethernet interface for handoff, and provides the same characteristics as if it were running over native Ethernet. Excuse me. So the EOX gateway provides Ethernet over X or Ethernet over anything aggregation, and so it'll basically add or remove these different layer 1 technologies, be it SONET or WDM or DS Ethernet over PDH, for example. It provides that protected handoff to the retail provider, and it meets those diverse ENI requirements that I talked about a couple slides ago. But very importantly, though, it provides that standard MEF26 ENI handoff. So now you have a standard way, although a very flexible way, of handling all those differences between different retail provider requirements at the ENI. And by now supporting this MEF Ethernet access service definition, now we have a common service definition regardless of whether it's over SONET, over bonded T1s, over WDM, over native Ethernet, or over Ethernet over DSL. It doesn't matter. It's a common service definition. So now this allows that wholesale access provider to deliver a common service definition over a common peering interface, the ENI, to reduce the complexity of creating peering agreements. Now, if we put this all together, this is kind of at the ENI side. Now, if we take a look at this if we take a look at this so we looked at it from the right side of the diagram at the ENI side over different access networks, and now you have a number of customer premise equipment, EOX access equipment, to be able to connect this up to the UNI. And now the EOX access equipment will really vary depending on which access technology you're feeding into the customer premise, but also more importantly, whether you want something simple like a NID device. So for example, Ethernet over fiber using a FlashWave 9410 NID that allows you to provide basically a very simple Ethernet demarcation device to a FlashWave CDS, which is a micro-packet optical networking platform that allows you to deliver more sophisticated connectivity over protected rings, for example. And as you go down the chart, you can deliver Ethernet over PDH, where you can bond together DS1s or provide Ethernet over DS3, which gets muxed up into SONET eventually in the network, or Ethernet over DSL or over copper with a DSL CPE, and then finally Ethernet over SONET, providing connection-oriented Ethernet over SONET using, for example, the FlashWave 4100 ES micro-packet optical networking platform. So now you have the complete access solution providing EOX access at the UNI side, at the customer premise side, and EOX aggregation at the peering point. So this allows you to unify your Ethernet access services following standard MEF definitions over any access network technology. And so one of the things that this EOX Gateway and EOX Access products provide is it makes the network, this access network, look just like an Ethernet network. So you have Ethernet in, Ethernet out, but it's running over these different access technologies that you already have deployed in your network. So how do you leverage those assets to get the most return on investment from them? So I'd like to next talk about Ethernet exchanges briefly. And so Aaron provided a definition earlier where an Ethernet exchange basically provides you have this peering point with ENIs to interconnect a retail IP, Ethernet, or cloud service provider up to the exchange. So they're basically connecting into the exchange, and then you have a wholesale Ethernet access provider through an EOX gateway connecting up to that ENI. So the EOX gateway focuses on sort of the left side of the diagram where you're providing, it's focusing on the problems that need to be solved by the wholesale Ethernet access provider by normalizing the technologies, coming up with a common Ethernet service definition. It accommodates that diverse set of provider requirements both on the wholesale access side but also at the peering point. And it also provides an MEF26 compliant ENI to provide a standard interconnect to the Ethernet exchange. Now, if you look at the Ethernet exchange, it provides important functionality on the right side of the diagram where it normalizes the Ethernet service capability differences between that peering provider's network, because everyone has a slightly different thing. So they're providing sort of that normalizing function that the EOX gateway provides for the wholesale access provider. They provide it to the retail provider. They also they have to accommodate by definition a broad set of provider requirements because they have lots of different providers with lots of different capabilities. And then finally, they're migrating towards an MEF6 compliant ENI. The reason they can deliver that today, but the reason why they're not quite there yet is because most of the providers that connect to an exchange do not support the MEF26 ENI, although they're moving in that direction to provide a standardized ENI. So if you take the EOX gateway plus an Ethernet exchange, it really simplifies this solution to reduce time to revenue, so you can connect up, the wholesale provider can connect up to a retail provider much more quickly with standardized service definitions and standardized interfaces. And so finally, when you put this all together, as you saw the previous slide before, you have the EOX gateway up to the ENNI, and then this allows the wholesale provider to provide direct peering agreements with the retail providers, or to connect through an Ethernet exchange and provide sort of an indirect connection to the retail providers through that Ethernet exchange. So it allows them the flexibility of offering both, because today they predominantly have direct peering agreements with the retail provider, but want to look at migrating to look at new business opportunities through an Ethernet exchange provider. So the EOX gateway allows you to open up your access network for more service revenue, and the Ethernet exchange allows you to reach additional buyers of a wholesale access provider services. So I'd like to close this out with a poll, and then we'll jump over to Jeff's section. So the poll question: so do you require network infrastructure changes to deliver Ethernet access services? So pick one of three here. So one is you do need to upgrade your network to deliver these Ethernet access services. The second one is you can deliver over some of your network, so maybe you can deliver, for example, Ethernet over SONET as an access service, but not necessarily your other, you can't deliver it over other access technologies. Or maybe you can deliver Ethernet access services over all your network infrastructure today. So we'll give a moment there for people to fill that out, and let's see if we had some questions come in.
Ralph, I did see a quick question, and I know it's difficult to talk about it when one of the slides isn't up, but a few slides ago where you were talking about the EOX gateway and the Ethernet exchanges, you had clouds on the left and on the right and the EOX gateway in the middle. Could you just give a little detail on who owns the EOX gateway? Would it be the wholesale provider? And where does it sit? Does it sit on their network? Does it sit in the Ethernet exchange facility? Or a little more detail on that would be great.
Okay, great. Thanks, Aaron. That's a great question. So in the slide that Aaron's referring to, where I showed the EOX gateway is owned and operated by the wholesale access Ethernet access provider, and the reason being is it's managed by their OSS systems, and so they provide a standard MEF compliant ENNI to either directly to their retail provider partner or to an Ethernet exchange. And so the reason why they would manage it is because it has to do with all the uniqueness and the technology differences within their network, and it normalizes that function. So it really makes sense to go there. The Ethernet exchange provider is providing you can think of it in simplest terms, providing cross connects, but only using Ethernet technology. The exchange providers are not, Ethernet exchange providers in particular are not providing interconnects for technologies other than Ethernet.
Great. Thanks. That pretty much addresses the one question I saw float through.
Okay, so let's push these out. So what we have here is, so it looks like pretty much what I would have expected. So you can deliver Ethernet access services over some of the network infrastructure. So if you imagine a service provider has both legacy infrastructure they may have had in place for a long time, and then they have newer infrastructure, newer build that they do incrementally over time. So there's this sort of diverse mix of technologies in their networks, and so as expected, I would expect them to be able to deliver Ethernet services over at least over some of it, but not necessarily over all of it. So let's go ahead and what I'd like to do is introduce our next speaker. Let me push your slide out here, Jeff. So Jeff Brown from Covad Wholesale. Jeff, the mic is yours.
Yeah, thanks, Ralph. First of all, our company is Covad Wholesale. We recently completed a merger with both Megapath and Speakeasy, so we're in the middle of a brand transition. You'll hear both Covad Wholesale or Megapath Wholesale mentioned, same company. We'll be converting over to the Megapath name here shortly. Wanted to talk a little bit about our Ethernet services and exchanges. Some of this most of you know about. why Ethernet. The point that probably hasn't been brought up before on the presentation is the price per meg. You don't typically see in an Ethernet over TDM where the access is still TDM, where you don't get those type of efficiencies. In a pure Ethernet deployment, you'll get an attractive price per meg relative to TDM-based services. Also, the flexibility, as we mentioned, being able to increment up with more various types of bandwidth than what you get in the traditional legacy architecture. So as Ralph mentioned, one of the access technologies that carriers use is Ethernet over copper. You'll see it with the periodic chart, EOCU. We will simply refer to it as EOC. The primary driver behind Ethernet over copper is that approximately 3/4 of the business buildings in the U.S. don't have access to fiber. So as I mentioned earlier, and everyone would agree, fiber is the ideal access technology. However, for 3/4 of the businesses in the U.S., it's just not going to be cost effective. So your choices are typically either Ethernet over DOCSIS, if it's available, and in many cases that's a residential deployment, so it may not be available in a business setting, or Ethernet over copper. So we've chosen to deploy Ethernet over copper. We leverage our physical co-locations that we have with the ILEC. Our company actually has over 2,000 physical colos that we've had for a number of years. We deliver the service over what is referred to in the industry as dry loops. You'll also hear unis, unbundled network elements. So we essentially are using copper, underlying copper DSOs with the G-Schitzel technology and EFM bonding, which is Ethernet first mile bonding. We offer symmetric data rates, from 2 to 20 meg. I would also mention that you'll probably hear some references out in the industry to bandwidths that go above that. The capability certainly exists to provide service well above 20 meg with both the vendors and the chipsets and the access. We've chosen to take a deployment where we want to sort of under-promise and over-deliver. So we feel very, very comfortable today that we can provide up to 20 meg symmetrical service in any place that qualifies successfully. So, as we mature the product, we're going to be able to roll it out to speeds higher than 20 megs. So it's definitely got some scalability with the solution. It is a distance-based service. There is degradation over copper, so we typically will consider addressable buildings where we can provide service to mean any business that is around no more than 12,000 feet from the central office, or basically, roughly speaking, about a couple of miles away from the central office. We do have business class SLAs associated with the service. In terms of installation, you see the mean time to repair, 4 nines availability. One point I want to mention about the latency, it's a very strong 10 milliseconds within the region. So how do we define a region? For us, we have 12 regions around the country. Most of those are multi-state regions. So, for example, Texas, Oklahoma, and Louisiana comprise one region. So if 2 endpoints were going to be delivering service, we guarantee a 10 millisecond within that region. And then cross-country, for example, Boston to Los Angeles, our SLA covers 80 milliseconds. Real quick description of the Ethernet traffic flow. Starting off to the left, we have a couple of different type of deployments with the CP. You see the green box there saying the 838, either acting as a router or with a router behind it in bridge mode. Going through our access concentrators, we have an ADTRAN deployment for the access side of it. You can see where Fujitsu is a very key partner for us. We're using the FlashWaves, both the 4100s and the 9500s, to carry that Ethernet traffic from our edge via Ethernet over SONET currently today, and then we convert it back into native Ethernet. Now we have 3 different ways to hand off the traffic in a wholesale environment. At the top right there, you'll see a cloud for internet. We can either pass the traffic directly to one of our core routers where we have peering agreements with internet service providers, and we can provide what's typically in the industry referred to as a DIA service, dedicated internet access service, where we're providing an end-to-end solution. Probably the most common type of traffic handoff, and Erin mentioned in her stats, is a direct peering relationship that we have. You see the cloud that says L2 partner, so a layer 2 interconnection where we have a direct peering relationship with a carrier or a wholesale provider. And then relevant to this topic, the third type of traffic handoff would be to an Ethernet exchange. So we would have an actual ENNI to ENNI type of handoff between ourselves and the Ethernet exchange partner to be able to pass traffic to the buyer who's also a partner within that Ethernet exchange. So where is the service available? You'll see the gray column on the left. Last year, we deployed the service throughout Southern California, a fairly dense rollout to 100 central offices in the greater Los Angeles area. It goes as far north as, say, Sherman Oaks down to just a little north of San Diego. It covers both the incumbent, Verizon and SBC territories. In terms of addressable buildings, we can address or provide service to up to 500,000 business buildings in that greater Los Angeles area. So those are all businesses within 12,000 feet of the COs where we're co-located. And our strategy was to make sure that we could provide a true carrier class offering to our service providers and make sure that we could deliver and provision and maintain the services in a carrier class type of manner. So that service has been operational, commercially available for well over a year. So now if you move to the middle column this year, now that we've successfully completed our merger, we are actively building out these top markets across the U.S. You see the 14 markets that are going to be available this year. It totals 300 central offices where you'll have availability. And then if you look above in the rectangular box, in terms of addressability, that's 1.5 million businesses that will be able to, or our wholesale customers will be able to reach. Those new markets, some of them are actually launching in a few weeks in July, so that service is becoming readily available quickly. And then over to the farther right, 2012, we're going to expand further and address another 1 million businesses, another 250 central offices. So we're going to fill out some of the existing key markets. So there are some less dense central offices in terms of businesses that maybe weren't at the top of our business case. We're going to go ahead and fill those out, and then we're going to also add some additional new markets like some of the ones mentioned here. I will point out for those deployments that are further out, we are really going to be relying on our wholesale partners to help drive and influence where those additional markets are that we build to. This is just a visual depiction of the Southern California footprint, 100 central offices, so it's a very dense rollout. Everything that's in blue, shaded in blue, are areas where we can provide this service. So again, it's a 2 to 20 meg Ethernet wholesale access service that crosses both Verizon and SBC territories. Tried to give the best visual depiction of our expansion across the country. It's hard to do on one map, but you can get some representation here of all the markets that we'll be going to both this year and next year. You can see a high concentration in the Northeast and in all of your what you would call your NFL markets. So Ethernet exchange considerations. We consider partnering with an Ethernet exchange company a separate distribution channel from our direct peering. So we continue to have direct peering relationships with existing partners, and I'm sure we'll have new ones as well. It's just going through an exchange is a separate distribution channel, another way to distribute your product. You can be a buyer or a seller in exchange. We have currently been a seller. We are also planning to be a buyer as well for services. We are actively selling via One Exchange, so we have our Ethernet over Copper MEF compliant service available in Southern California. We actually have turned up multiple customers. As we are expanding the service, into areas like the Northeast and Chicago and places like that, we are actively talking to some of the other exchanges and then other exchange locations with those exchange partners. So we're under contract with some, and we're in interop testing with multiple exchanges, and we're trying to time that rollout to coincide with our Ethernet over copper rollout in those markets. One thing to consider, or some things to consider when you're talking about doing business with an exchange, whether it's a buyer or as a seller, and these are things that we thought about. The first is, does that exchange provider have an international focus versus strictly a domestic focus? For us, as a national U.S. carrier only, we were more interested in, obviously gateways and exchanges, physical exchanges that were located in the U.S. So that is something to consider. An Ethernet-only focus versus, handling multiple types of traffic. So we don't wholesale voice services. So for us, we were looking for someone, for partners, exchange partners that had a strong proficiency around Ethernet services and a business focus around Ethernet services. But certainly, if you were, for example, in the voice business, you would want to make that a consideration too. Voice peering has some similarities to Ethernet peering, but there are also some substantial differences, and you need to take that into account. There are different pricing models to consider. Some have a little more onus on the buyer, some more on the seller, and those are also considerations that you want to think about. Physical co-location is certainly important. If you're in the business already of being a wholesale provider, being a carrier, you more than likely have physical co-locations in some of the, quote, carrier hotels. So obviously it makes sense if you're already paying for that floor space to go ahead and just turn up an NNI with an Ethernet exchange. Is a lot simpler to do than perhaps having to go several miles out of the way to establish physical connectivity and a co-location space with an exchange provider. And then the last are addressability issues. So there's a lot of details with Ethernet over copper around pre-qual, and it's important that the potential buyers be able to really understand where they can get the service. So having an exchange partner that has a strong portal where they can actually see your addressable buildings, they can actually pre-qual down to the service level type and bandwidth type is very important. And then, of course, how they pass the order on to you. There are different ways to do it in the Ethernet environment. It's not like in the TDM world where there's a standard ASR. So there's some devil in the details about how you can actually take the traffic from an ordering standpoint and provisioning standpoint. So those are all things to think about when you're talking about either buying or selling Ethernet services with an Ethernet exchange. And that is my last slide, so now I will hand it back over to Ralph.
Okay, great. Hey, thanks a lot, Jeff. That really interesting, that last slide there you had, there's a lot of considerations, that you mentioned there. And obviously, COVAD is, being in the wholesale access space has to think through all of those, and it was really good for you to provide that type of perspective, the similarities and differences with other type of peering that can be done. And yeah, so that's great. So what we'd like to do now is push out another poll. This will be our last poll for today. And the poll is, do you plan on purchasing Ethernet access services through an Ethernet exchange to reach off-net customer locations? So your choices are no plans to do it. You're currently evaluating. Now this is a paper evaluation as opposed to testing it out in your lab. The next one is in trial, so you're actually testing it, physically testing it, let's say in your lab or with an Ethernet exchange provider. And the last choice is already purchasing the services through an Ethernet exchange. So we give a few moments to fill that one out. And I think as we conclude here, this is our last poll. Just check if we have any more questions here.
I did see a question come on that had asked about Jeff, about what gear he was using, and then the next slide showed up with him talking about the Fujitsu gear and how he's using it. So I always find that interesting, that the mark of a really good presentation is when your question is answered on the next slide.
That's right.
So kudos to you, Jeff.
Oh, thank you. Fujitsu, of course.
Mm-hmm.
Okay, I'm going to go ahead and push these poll results out. So, okay, so it looks like pretty much currently evaluating for our audience today. So not surprising, but I don't know, Jeff, do you want to comment on that? As COVAD went through, sort of this evaluation process on their own, and looked at different Ethernet exchange providers. What are your thoughts on kind of the state of, based on this answer here, kind of the state on where Ethernet exchanges are, from all the way from evaluation all the way through deployment?
Yeah, I mean that question has a lot of layers to it. You could spend a lot of time talking about it. I would say my personal, professional view is that the companies that decided to go into the Ethernet exchange business have some exit strategy or some further strategies that go beyond just being an Ethernet exchange provider, because the bulk of the Ethernet business that's being passed back and forth today is done via direct connects. Now there is, I believe, certainly emerging markets for companies that aren't traditional telecom providers, that aren't traditional carriers, that may need Ethernet services, and they're looking for a simple way to interconnect and be able to get service from different providers without having to hire massive IT staffs and go through all of the vetting that goes through that process of vetting each provider's Ethernet service. As you know, everybody's Ethernet service is slightly different from each other. So, when you, not to use another popular buzzword, but when you think about, cloud services, and that can mean a lot of things to a lot of people, but when you think about the companies that are in those spaces and want to be in that space offering cloud services, a lot of them are not your traditional carrier, and so they may not have the in-house expertise or may not care to fund that type of expertise to be able to efficiently and effectively purchase Ethernet services, and they might consider an Ethernet exchange an effective way to do it.
Great. Erin, any final thoughts on that, or?
I think that what Jeff had said says it pretty much perfectly. I think he was talking about on my last slide. I had listed all the participants or the potential participants in the Ethernet exchange, and we're seeing a lot of interest from that group that he was just talking about. The cloud providers. I know we hate to use the word cloud, and then everyone uses the word cloud. And specialized providers. Exactly what Jeff was saying. The folks that don't, like a Salesforce.com or someone like that their business is not expertise in networking. Their business is delivering a specialized software program or cloud-based program that allows other companies to do business better. And they don't want to have to deal with, as they said, big IT departments. So it's a great option for a lot of those folks. So we're seeing some real interest in that.
Great. Well, thanks a lot, Erin. Well, we're just about out of time, and I'd like to thank those who attended today. And I also like to, more importantly, thank our speakers today, Erin Dunn, Director of Research Services at Vertical Systems Group, and Jeff Brown, Vice President of Carrier Services at COVAD Wholesale. So thanks a lot, everybody. Thank you, Erin and Jeff. Great presentations. And we look forward to having you attend our future Carrier Ethernet webinar series. And you can visit our site at us.fujitsu.com/telecom to watch a replay of this webinar, as well as see dates for future webinars and be able to replay past webinars. Thank you very much, and have a great day.